Um, Thanks for inviting today. Great content. And this is definitely a different perspective on edge computing and what and how AWS can help accelerate your innovation at the edge. Good afternoon, everyone. I am Ram Konchada. I am a solutions architect, senior solutions architect at AWS in the enterprise segment based out of New York City. Prior to AWS, I've been an account manager for a number of years for General Dynamics Information Technology, GDIT, if you heard of them, modernizing air traffic control systems. For the next 15 to 20 minutes or so, I will talk about the typical challenges at the edge, what are the use cases, and how AWS helps our customers solve their challenges. So, top three challenges that our customers are facing with computing at the edge are like number one, to process the data locally with the disconnected systems, like, for example, oil rigs, disaster recovery sites, etc. And the second is like when customers have like hundreds of terabytes to petabytes of data to migrate to another location or to AWS cloud. And the third is to like move the data when there is little or no bandwidth, right? Especially in the remote and rugged locations. So with those challenges, right? So it really boils down to two use cases. Data is hard to move with little or no bandwidth, right? And the second use case is the collect and process data at the edge for the bandwidth constraint, like I said, rugged, non-data center locations, like with no infrastructure, such as like the remote clinics, disaster recovery sites, factory floors, etc. So these are the use cases that AWS Snow Family addresses, right? So before I jump into the specifics about the Snow Family, I'll share like a short story on how Snow Family has evolved, right? So the first time Snow was created, it was actually a secondary product after a team of like 8 members created the import-export disk service in 2010. And as a means to support the customers transferring their data offline onto AWS by shipping their hard drives to their AWS regions. So that created like really all kinds of complexity at the overhead, right? So due to the fact that like hard drives can fail, can have different interfaces, pins can bend, a very cumbersome and bespoke process. It was recognized pretty quickly that it can also lead to like some security vulnerabilities, right? So to overcome that problem, AWS considered creating their own device, and hence the Snow Family. Snowball Edge is the first one that was created with the Snowball Edge device, right? So the encryption piece of the data that is getting copied over to the device that moved to the device instead of from the customer's workstation, right? So that introduced the possibility of doing computing on the Snowball device at the edge, because it's the same device that's used for to do the encryption when customers move their data. So basically, we designed a product to move the data, we added compute to it and to do the encryption, and we made that compute available for customers to do the local processing. So that's how we ended up today with the Snow Family at the edge. So this edge computing then really opened doors for a lot of use cases, right? Like IoT Hub to analyze the sensor data locally, doing some machine learning inferences at the edge, maybe video and audio image processing, actually. So processing data, right, at the source. We have like 2 devices that I mentioned about the Snow Family, which are like Snowcone and the Snowball Edge that I'll be talking about. AWS offers like 2 options for computing at the edge, right? So the first is like the AWS Outposts and AWS Snow devices like Snowball Edge and the Snowcone. Although this session is focused on the Snow family, I think it'll be a good idea to take a couple of minutes to talk through the environments best suited for AWS Outposts versus AWS Snow family, which in this case, Snowcone and Snowball Edge. For Outposts, as you may have heard, like they are designed for traditional, fully connected data center environments, such as like customer premises, co-location facilities, and telco central offices. Essentially, outposts are used when connectivity is good. But so built up in the data center space is needed for the outpost, right? You can provision, log, and control services on outposts from the AWS console. Replacements and upgrades are performed in the field. So to the contrast, right, like Snow family, the Snowball Edge, they're designed for non-traditional, disconnected or intermittently connected environments, like such as remote and austere locations and all manner of commercial, industrial, transportation, and military use cases, which I'll touch upon a bit. But it's basically where there's no built-up data center space. That is where like the Snow family really thrives, right? Currently, there's no control plane actions such as like provisioning, logging, or monitoring that can be performed from the AWS console, and no repairs on the field, right? Capacity expansion is only through the additional units. So how does a rugged edge compute look like, right? So this is an example workflow that shows like what it means to run a connected, or in this case, disconnected from AWS cloud. In this example scenario, like you have industrial machines generating data or medical instruments generating the data from the medical facility. Snowcone is a perfect fit for these use cases. Copy the data onto Snowcone, either wired or wirelessly over the Wi-Fi. To set up the compute application on the device itself, like you have two options. You can develop an application on an Amazon EC2 instance, and once validated, you deploy onto the AWS Snowcone or Snowball Edge device. And the second option is to develop an AWS IoT green graphs applications. And once developed and validated, likewise, you deploy and run it on the AWS Snow devices. So it also provides the EBS compatible volumes for your compute applications, in addition to like NFS file interface for copy and collection of storage or Snowcone devices, right? Given its small form factor and ability to withstand like sun, dust, moisture, Snowcone is a perfect fit at the rugged edge locations. It also provides a consistent DevOps model, very similar to AWS Cloud. You validate, run, test your applications on the cloud. Once it's all successful, you deploy it on the device. So how does a Snowcone device look like, right? It's a small, portable, secure, rugged device to carry edge computing applications or transfer data to and from AWS. Devices are secure, automatic 256-bit encryption as it copies data, and the keys are not stored on the device. It is lightweight, just 4.5 pounds that you could carry in a backpack, or it could be put on a drone as well. It can withstand extreme climates like freezing cold, rain, very hot temperatures. Device has 8 terabytes of usable storage. Data is encrypted on it locally before you upload to AWS. Once copied onto the device, once the data is copied, onto the device, there are like two options. One is to ship the device to the AWS region using your standard shipping methods, or for offline transfer, that's the second option, is at the edge locations, right? So the connect to networks and transfer to AWS using the AWS data sync service. It has two CPUs and 4 gigabytes of RAM available for edge compute applications. For example, if you're familiar with existing AWS EC2 instances, like P2 instances could be run, or two T2 micro instances or medium instances can also be run on these devices to perform some lightweight local processing. So when a Snowcone, I just want to go through the various features or feature set from Snowcone perspective. When it was introduced, it took the concept of data movement from the Snowball Edge and the original Snowball, which is an offline import-export of data to Amazon S3 by the shipment of a device. So we can also import online, right, with the Snowcone devices to Amazon EFS and Amazon FSx for Windows using the service called AWS Data Sync. It supports the Wi-Fi. You can run applications developed, like I mentioned, on EC2 or IoT Greengrass functions. So it's our first device that supports running off of a non-wall plug-in based power, right? With a 45-watt battery and with 25% utilization CPU, Snowcone can run for about 2 hours. You can provide larger batteries via the USB-C port type connection for power and run for a longer duration of time. You see, it has some capabilities similar to Snowball Edge, like running in harsh environments, non-filtered air, non-data center, non-conditioned environments, right? It can also withstand a drop of from 4 feet high. So you operate this device through a very easy to use interface called Ops Hub interface that AWS provides. This slide shows you some examples of like how a Snowcone can be used. Can be used in healthcare facilities, like outside environments, like war zones, as you could see, and that are environments like that are resistant, like high moisture, right? Like can also be used and could be carried from a drone camera in locations where you'd like to use it, and where in inconsistent power supply, like the construction zones, etc., just because it can run on a battery for a couple of hours with a decent CPU utilization. Brief overview on two options that are available with the Snowball Edge devices. It has two flavors of the product. The compute optimized is one, and the second is the storage optimized. We do offer long-term deployment options for 1 year and a 3 year, along with a little bit higher price for monthly and half-year lease terms as well. In the compute optimized, you get significantly more CPU resources, the way it sounds, right? Like it has like 52 vCPUs and 208 gigabytes of memory. For customers who are willing to like do more inference processing, like we do also offer NVIDIA Tesla V100 GPU as an option as well in the compute optimized. So the second option where most of our customers choose is the storage optimized, just because like for most of the use cases, storage optimized meet the requirements. It runs a little bit less of the compute with the 40 vCPUs and about 1/3 of the memory compared to compute optimized with 80 gigabytes of S3 compatible storage. And both these devices can run in clusters. That's an interesting feature. So I want to walk you through typical use cases that customers run on Snowcone devices. Like first is the industrial IoT, like construction sites, oil rigs, mines, where you have a limited network connectivity, uh, and you bring the data back to AWS from these ruggedized devices. The second is the healthcare facilities where we see most usage in. You capture the data from the medical instruments, you capture the data from emergency vehicles, carry out the edge computing applications, and then securely transfer data in some cases real time to AWS for further processing. The third is the content distribution use cases where content is stored in AWS and distributed to customers or partners like the media, financial, and other content. Uh, the other use cases like the content aggregation, where we're seeing a lot of acceleration in adoption. This could either be from the rugged locations, like where there's no connection to AWS again, and it could be like movie data from the movie cameras that is collected in the from the remote locations, and the data is brought back to AWS for further post processing. Uh, you could also use collect data from autonomous vehicles and to get to the locations, and for further processing, data could be sent to AWS. Finally, I want to end the presentation with this last slide with the additional variety of ways how AWS offers from cloud to the edge. We call it to edge to the cloud continuum, right? So starting from the right, as you all know, like AWS Cloud and how applications run in AWS, customers have all the elasticity, scalability, resiliency with the DR capabilities through our HA region strategy. So as you move to the left, if you're following my cursor, we spoke about the Outposts, which is really an extension of AWS infrastructure to your on-prem environment. And then moving a little bit left, so we talked about the Snow Family, Snowcone, and the Snowball Edge devices that solves the edge computing use cases at the ruggedized locations. And really what I want to highlight is, in addition to Outposts and the Snow Family, AWS Wavelength, right? Like this enables developers to build applications to deliver like a really single digit millisecond latencies to mobile devices and the end users. They deploy their applications to wavelength zones that we call at the edge of the 5G networks. And this is a perfect use case for gaming and augmented virtual reality use cases. And another service that I wanted to mention is like the AWS RoboMaker. It enables robotic developers to build, test, and simulate robotic applications and then deploy to the edge in, for example, in the production robot fleets, right? Factory floors, etc., for robot fleet management. That's all I wanted to share today about how AWS helps the customers innovate at the edge. And thank you, everyone, for giving me an opportunity. Thanks, Ron.